show that the tangent to the circle x squared plus y squared minus 169 equals to 0 at the 2 points 5, 12 and 12, negative 5 are perpendicular to each other. Let us begin. So here we have the equation of the circle which is given to us. We have x squared plus y squared minus 169 equals to 0. So what we'll do, we will compare this particular equation with the general form of a circle. So the general form of the circle is given by the equation x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. And this immediately gives us the value of the constant g, f and c. So 2g will be equals to 0, 2f will be equals to 0, and the c value will be negative 169. So g will be 0, f will be equals to 0. Fine. Now we have 2 points. So here let's say we have the circle, and on the circle we have 2 points. Let's say one of the point is having the coordinates 5, 12, and we have another point with the with the coordinates 12, negative 5. Now at each of the 2 points we have a line which is tangent to the circle. So let's say we have a line which is tangent to the circle at point A, and we have another line which is tangent to the circle at point B. So our goal will be to show that these two tangents are perpendicular to each other. Now we know that there's an equation of the tangent line which is given by the point form. The point form of the tangent line is given by the equation x times x1 plus y times y1 plus g multiplied to x plus x1 plus f multiplied to y plus y1 plus c equals to 0. Now here x1, y1 will correspond to the coordinates of the point of contact. So if we consider the point A, 5, 12, so here the x1 is going to correspond to to the value 5, and y1 will correspond to 12. So that means the equation of the tangent line will be 5x plus 12y. Now luckily the values g and f, that's 0, so we don't have to worry about the third and the fourth term. So we have plus c, so c being negative 169, we get negative 169 equals to 0. So this is going to be the equation of the tangent of one of the line. So let's do one thing, let's rewrite it in the slope intercept form, which is the y equals to mx plus c form. So we have 12y equals to negative 5x plus 169, or dividing each terms by 12. So 12 will be equals to negative 5 over 12 times x plus 169 over 12. This gives us the slope of the line. So slope of the line through point 5, 12 is going to be negative 5 over 12. Now we come to the second point B, having the coordinates 12, negative 5. Now we can again use the point form to obtain the equation of the next tangent line. So we have 12 times x minus 5 times y minus 169 equals to 0. So we're going to rewrite it in the slope intercept form. So to 5y will be equals to 12x minus 169, which means y value will be equals to 12 over 5 times x minus 169 over 5. Now the slope of the line, tangent line through the point 12, negative 5 will be positive 12 over 5. Now that we have the slope of the two tangent lines, let's suppose that the slope of the tangent line through point A is denoted by m1, and slope of the tangent line to point B be denoted by m2. And clearly we observed here that the product m1 times m2, that's equals to, so we have negative 5 over 12 multiplied to 12 over 5, which gives us a value negative 1. Now we know by the property of straight lines that if the product of the slopes of two straight lines is negative 1, then the two lines must be perpendicular to each other. Hence we have successfully showed that the two tangent lines to the circle whose equation is given to us at the point 5, 12 and 12, negative 5 are going to be perpendicular to each other. Hence proof.